Hello, everyone, and welcome to Disrupt Health Tech. I am your host, Wendy Austin, and today I'm talking with Vinodh Balaraman. Vinodh is a world-class healthcare executive with a proven track record of building technology-based businesses where he achieved multifold growth in multiple situations. His previous achievements were at ZS Associates, a leading life sciences strategy consultant senior partner, and at Atos, a SVP and head of digital tech foundations. He has advised and mentored various startups in the healthcare space. Welcome, Vinodh, and I'm so happy that you joined us today to talk about Hemato.AI.
Thank you, Wendy. Great to be here.
Great. So, Vinodh, you've described your company as a disruptive deep science startup doing some exciting innovation in the Hemato-pathology field. With AI. Do you mind telling everyone why your company, Hemato.AI, is disrupting the field?
Yeah, certainly, Wendy. That's a great question and a great way to start. So Hemato.AI, as you briefly mentioned, we are a hosted AI service that analyzes peripheral blood films or peripheral blood smears to automatically diagnose various diseases. What we do kind of it's right at the core of hematopathology, and it's essentially taking digital pathology to the next level by not requiring human experts to do something that is highly manually intensive and difficult to do. So let me give you the context of where we come in. So I'm sure everyone has heard of the CBC, or the complete blood count type of blood tests that are fairly common. Those tests are done by automated hematology analyzers and yield a certain amount of information that is not the be all and end all, in terms of diagnosis of disease. So a lot of times from a CBC, about 15 to 20% of the cases are referred for a more elevated study called a peripheral blood smear study. And that's where we come in. This particular study, the peripheral blood smear study, is done by expert hematopathologists looking at a glass slide image through a microscope. And it's a manual, expert-intensive and effort-intensive process that can sometimes, it'll take several hours to several days, particularly given the relative shortage of pathologists that is getting worse by the day. And also the fact that it takes a pathologist up to, potentially 15 to 30 minutes for each individual blood slide. And it's not cheap either, as you might guess, right? So what we have done, of course, is we have leveraged AI along with our expert clinical algorithms to essentially do this peripheral blood smear study in a matter of seconds and for essentially almost no cost, literally pennies for each test. And most importantly, we can do this without any experts. And therefore, this gives you the flexibility to do this anywhere, anytime, and it's completely digitized, right? So that's the great innovation that we're bringing to the picture. And we believe as this gets accepted, this will really change the game in terms of pathology, because it can, you can do this at a much more frequent level. You don't have to do this occasionally, only on 15% of the CBCs. You can literally, over time, start doing this every time you have blood, which in turn will make it much simpler to potentially earlier detect a lot of diseases.
Yeah, very good. So what sets you apart from other players in the digital pathology fields?
Very, very, very good question. So in fact, we are quite distinct from the other players that have come into the digital pathology space. And let me explain specifically where we're distinct. I would point out four major distinctions for us. Number one is we go the whole way to do a full differential diagnosis. We don't just stop at providing decision support to the pathologist. So we will do the entire diagnosis and write the full pathology report, which is meant for action by an attending physician without the involvement of human experts. Number two, we function as a general purpose diagnostic. What I mean by that is we are not a custom diagnostic that is focused on a particular disease or a particular condition. When we look at the image of the blood slide, we can, in fact, identify and diagnose anything that may be wrong with it, any type of conditions that may occur, which is really what you need in a true automated diagnostic system. Because if a lot of times the patients come in with what you're thinking it might be may not be what it truly is, and often there's also comorbidities that are important to capture up front instead of getting down the road. So the general purpose diagnostic is a key distinction. Number three is that we are completely hardware independent. We don't have our own proprietary hardware, which is proprietary hardware often can be expensive to procure. So we will work with any image that is interpretable or analyzable by a human expert. So that if it's good for a human expert, it's good for us. And number four, we play in hematopathology, which interestingly, in all the different components of pathology, is probably the least penetrated or digitized space. It's got its own set of nuances. I mean, much of the focus of the digital pathology players tends to be on the anatomical pathology side, not on hematopathology. But we believe hematopathology is at the root of a lot of things that happen and can go wrong to human beings, right? So those are our key distinctions. And I will also mention that the secret sauce that we have built took us about 2.5 years to develop. So it didn't happen overnight. And it actually, the simplest way to explain that secret sauce really is the way we have amalgamated AI with clinical expertise. So the data science expertise and clinical expertise coming together to actually function like a human expert and come up with an answer similar to the way a human expert does, except we do that in a matter of seconds with a higher accuracy rate and obviously with almost no cost, right? So that's basically it in a nutshell.
Because this is digital, I'm imagining that you're not actually in the labs, you're not in the blood, that this is all happening in like a digital image that's being passed over, or is that not the case?
No, you're correct. So and this would be, what might be referred to as a dry lab test, right? Okay. So as you just said, it is completely digital, and we don't need any physical presence in a lab. As long as we are able to access the image of the blood slide, which can most commonly in the Western world, many labs have whole slide imaging scanners. Alternatively, you can also upload photographs, of a microscopy image using multiple approaches, right? So there's simple cameras. You can use cell phone cameras, can be used as well in a low resource situation, right?
Very good, very good. So one of your co-founders, Dr. Zandi, has a quote on your website, and it states, "With the help of AI, human experts can focus on the most important cases while the AI makes sure nothing slips through the cracks." How confident are you that the AI will be accurate enough to be used in clinical settings?
Yeah, it's a very pertinent question. I think we have very strong results, and therefore we're very confident. We've built this what we believe to be the world's largest annotated data set of peripheral blood smears, and use this to train our models, which are now producing 95% specificity, which is quite excellent. Meaning the specificity is if how confident we are of the particular diagnosis that we're coming up with.
Right.
And then it's also producing 85% sensitivity, which is a metric that continuously improves as we are adding data to it. Obviously, the data set is not complete, and we're continuing to build on it. And so we expect the sensitivity to also end up in the 95, 97% range. With these kinds of figures, these are generally very, very strong figures and acceptable for use in potentially in clinical settings. And at the end of the day, the important thing is the AI does not make errors that can creep into a human's analysis. Even if the human being knows what he's doing, you're still human. So you may be subject to error, which we can avoid.
Yeah, very good. All right. So do you believe that this will change how we detect diseases early?
Indeed, it will. I think the way I would put it here is that as you know, in today's world, due to the cost as well as the bandwidth constraints and the cumbersome nature of these peripheral blood smears and related studies, they're not done nearly as often as they should be, right? So as I pointed out earlier, only about 15 to 20% of the CBCs get referred for a peripheral blood smear study, when in reality, you really would want to do this in an ideal world every time you drew blood, because this gives you probably the most amount of information you can get when you take a look at blood. And our technology, Hemato.AI, will make that world a reality, because in an eventual world where this is fully accepted and being used, you can certainly envision where you do not need to do this only on 15 to 20% of the CBCs. You ideally could do it 100% of the time you draw blood, right? And in fact, a good way to think about this is in other parts of the world where the CBC is not quite so established, or they lack equipment and resources to do the CBC, this may be a quick, cheap, and inexpensive way to directly go to the root and do the diagnosis of disease using our Hemato.AI technology, right? And but in the US and the Western world as well, I see this has the potential. The real gain here is that we can take a look at your blood every time you draw the blood. We can do a peripheral blood smear study, which in turn, on your question, can catch these diseases much earlier.
Yeah, wow, that's good. That's an interesting thought about being able to do this in countries where they may not have the ability to do the CBC all the time. So there's a lot of potential there.
There indeed is. In fact, the crazy thing about all of this is these countries which have the least resources also tend to have the most disease burden, right? So not shocking, but that's just how the way the world is. So you have a very significant need in all these other parts of the world, like sub-Saharan Africa or even India or other developing parts of the world. And, and this is a very good fit in those resource constrained situations, because you're not able to do a CBC. You certainly don't have pathologists. I mean, pathologists are in short supply in the US, let alone elsewhere in the world. So if this gives you a way to address that problem at its core, right? In a cheap and inexpensive way without needing those experts.
Well, and speaking of shortages, how do you think this might affect healthcare organizations that are experiencing shortages today, whether they're in the US or elsewhere?
Yeah, I in fact just came back from a conference called the Executive War College, where this is, it's probably one of the largest gatherings of pathologists and clinical labs. And this was one of the number one things they talked about was this upcoming shortage of pathologists and how digital pathology can help address that. So I think this, our technology gets right at the core of that, right? It's perfect in a world where we are forecasting a significant shortage of pathologists, and that shortage only seems to be getting worse because for various reasons, maybe pathology is not the top topic on people's minds as they study medicine. They get into other areas. It's, I don't know, for lack of a better word, maybe considered less sexy perhaps by some people, right? So, by the way, sorry, is that a bad word to use?
No, that's fine.
That's good. Okay. So
it's a marketing word for me. So
it's a marketing word, right? Yeah. So it sounds I thought it would sound natural if I said it, right? So
yeah.
So it's less, it's considered less sexy by certain folks, perhaps. So due to all these reasons, you're not seeing enough new pathologists coming out while the populations continue to grow in general and the demand continues to grow.
Yeah.
So a solution like this is really, it's necessary. It's not even optional anymore, right? And it's a matter of time, but we want to race to the finish and be the first ones to provide something like this, which can completely take away that need. Right,
that's great. And I totally agree. I think this will change a lot of, the future of what the mix between human and, for lack of a better word, machine, right, will be in pathology. All right. So how do you see your service being used in healthcare organizations or even in labs?
Yeah, we see two major types of customer segments or types of use. Number one is in a clinical setting with healthcare providers in actual clinical labs or in hospitals with labs or clinics with labs, right? So so we would, a perfect use case is leveraging our technology to automatically help diagnose various diseases and write pathology reports without leveraging human experts in the treatment of patients. And in that context, we also are a good fit to partner with device manufacturers and EMR providers.
Oh, very good.
As they play with all these clinical labs and hospitals, right? The second big segment or use case is in the research setting. So for research settings, when I say research settings, I'm talking about, both biopharma R&D as well as other just medical institutions, like university research institutions, medical institutions doing research in medicine. And so in these circumstances, either they're developing, developing new therapeutics or new treatments or new diagnostic approaches, and our technology is a great way to evaluate in translational research or in clinical trials how the drug is progressing or how the treatment is progressing in terms of efficacy and adverse effects. And it can also be a great way to identify new novel biomarkers or patterns that are not visible or identifiable easily by humans in order to find new ways to either diagnose disease or new ways to measure progress of disease, et cetera, right? So in that sense, this can be a great companion, what's called a companion diagnostic or a complementary diagnostic, right? That goes along with an existing treatment and says, okay, here is the set of patients with these types of biomarkers and these types of characteristics that would be a perfect fit for this kind of treatment, right?
Yeah. Well, that's actually pretty exciting because that means that they could potentially even in clinical research go faster if they're able to, take the images of the blood and be able to see what it's doing and have AI actually, help them with the diagnostics and everything.
Yeah, that's correct. I mean, as you can imagine, on the research side, again, as they are developing these treatments, they are evaluating the progress of the is this going well? Like if it's a leukemia treatment, okay, you want to make sure that things are not getting worse or the treatment is effective. So they're constantly checking the blood and leveraging pathologists and all the typical manual hematopathology processes to do that. And so, we can clearly do this in a much more seamless efficient, automated fashion on a large scale, particularly for these urgent conditions where you cannot, you cannot be waiting for too long before things get worse, right?
Right.
Yeah. And then the other, like I said, the other type of example in research is these identification of new patterns or biomarkers that can be indicative or helpful to diagnose a condition or the progress of a condition or whatever, right? So, in fact, we're doing we've just signed on with an exciting new client, which is a top U.S. medical school, in order to identify a new diagnostic for myelodysplastic syndrome, which is a kind of cancer.
Right. That's great. I can't wait to see what you guys do. And then let me just ask, lastly, what are your next steps for company? What would you like people to know before we're through today?
Yeah. So we're having very good traction right now in terms of signing on with customers. We've just secured 2 key paying customers. As I said, the first one is a large U.S. medical school, part of a very reputed university, where we're going to work with them jointly to identify a new diagnostic for myelodysplastic syndrome. Let me dive into that for a second. So the MDS, as it's called, or myelodysplastic syndrome, is normally diagnosed by doing a bone marrow biopsy, which is a fairly invasive procedure.
Yeah.
And our research project, which is a multi-year project, it's a 3-year project that we've just signed on, will look for new patterns and biomarkers in peripheral blood that can help detect and diagnose MDS. So if this is successful, this will be a game changer, because you can potentially, every time you draw somebody's blood, you can do a MDS screening on top of that, which can either be a great add-on or eventually replace this much more invasive bone marrow biopsy, which often, because it's so difficult to do, you don't end up catching these MDS cases on time.
Yeah, exactly.
And then the other big customer that we recently signed on is a large global device manufacturer that is making hematology, morphology devices, and we're partnering with them to provide our software service that can be integrated with their hardware through an API. So every time they pull a digital image of a slide, we can run our technology to do a full diagnosis and a pathology report, and it becomes a fantastic integrated solution that can go into all these clinical labs and hospital settings. So in terms of your question on next steps, we're actively involved in fundraising right now, and we are raising our seed round. So we, with this customer traction that we've gotten, this will allow us to be producing meaningful revenue this year. We're anticipating about 300 to 350K in revenue this year, but we would like to also raise some funding in addition to that to support our whole FDA process. So the fundraising will allow us to get FDA approval for a de novo diagnostic class 2, what that means is it's a new kind of diagnostic using our software as a medical device technology. That's what we're going for. That will obviously really put us right in front in this race to be delivering seamless AI-based automated pathology. We welcome any support and interest in that and in the fundraising process from everyone. And also the other part of it is, as we continue to build our business and advance ourselves, we're obviously interested in working with various customers in the provider and clinical lab space, or in the research space with pharma and medical institutions, right? So we welcome anyone that sees potential applications of our technology or would just like to learn more, to just pick our brain for something, we always welcome interaction and conversation on this topic, and we're looking to learn constantly, as well. So we welcome all thoughts and feedback, and anyone that would love to chat with us.
Very good. And I'm just going to put this up. So if anyone has any questions or would like to have any more information, please reach out to Vinodh or myself. And I've given a couple of websites down below for you to reach us at. And I want to thank Vinodh's time today and sharing with a very unique and very disruptive what you're bringing to the pathology space.
Thank you. Really appreciate that. Really appreciate the time to be on the podcast, and we look forward to interacting with any of you if you have questions.
Perfect. Thank you very much.
Great.
All right. Thanks for tuning in to Disrupt Health Tech. We hope you found our conversation today inspiring and informative. Remember, the key to success is using technology in an innovative way to improve healthcare experiences and patient outcomes. So keep a lookout for ways to challenge the status quo and keep innovating. See you next episode.